Good morning, all of you. I welcome Professor Vijay Kumar Garu, Professor Vijay Kumar ji from JNU, Jawaharlal Nehru University, New Delhi. Sir, am I audible, sir?
Yes.
Sir, thank you for giving this very good opportunity for us. Entire Andhra Pradesh faculty members, on behalf of AP State Council of Higher Education, sir, this is the initiative taken up by APSHE, AP State Council of Higher Education, especially the chairperson, Professor Madhumurthy Garu, with his visionary thought, he designed syllabus for AI, the mandatory syllabus, AI in fundamentals, as well as the applications of AI in various disciplines. It is a discipline-specific artificial intelligence applications are also there. As per our request, you are coming forward to deal with this, the computer vision and data.
No,
I would like
wisdom.
Yeah, wisdom. Sorry, sir. Wisdom. It is a wisdom, computer wisdom.
Wisdom.
The title itself is very beautifully designed, and this is also an application part of the engineering domain. I would like to introduce to the audience about Sir T.V. Vijay Kumar. Vijay Kumar ji is a professor in the School of Computer and System Sciences at Jawaharlal Nehru University. He has earlier served as Dean of School of Engineering and Dean School of Computer and System Sciences at Jawaharlal Nehru University, New Delhi. Also, he is a concurrent professor in the School of Engineering, concurrent professor in the Special Center for Disaster Research, and concurrent professor in the Special Center for E-Learning at Jawaharlal Nehru University, New Delhi. He has completed his PhD in the area of databases from Jawaharlal Nehru University. After completing his MPhil and MSc in Operations Research and BSc Honours in Mathematics from University of Delhi, his research interests are database management and distributed databases, data warehousing and data mining, artificial intelligence and machine learning, meta-heuristic algorithms and multi-objective optimization, data science and big data analytics, early warning systems and disaster management. He has served earlier as the International Students Advisor at Jawaharlal Nehru University and was also the founding director, Security Department at Jawaharlal Nehru University. And he is the founding professor at the Center of Excellence in Jawaharlal Nehru University, that is on artificial intelligence and machine learning. With this brief introduction, I welcome you, sir, and I give a big thank on behalf of AP State Council of Higher Education. Here, many participants are willing to join, and there is a live streaming also YouTube. This is also shared to our students so that they can be benefited. It is part of our core curriculum, sir, on artificial intelligence. As I said, there are two parts. One is the fundamental subjects, which is mandatory for all, and another is application part, that is discipline specific. With this brief introduction, I welcome you, sir. Now the floor is open for you. Thank you very much.
Thank you very much. My focus will be on wisdom from data. So my focus will be on AI, data science, and application of AI to different fields as designed by NITI Aayog, like healthcare, agriculture, education, smart city infrastructure, smart mobility, transportation, manufacturing, energy, retail. So, and disasters. So I will be talking at the end about their applications in these areas. I hope everybody can hear me.
You're audible and your PPT is also visible.
So, how many of you, what are the participants from? Which area? Are they computer science or other areas also?
Yeah, the participants mostly from engineering and computer science background, but there are diversified faculties also there, even from general education also there, sir.
Okay, so I will try to be very generic, layman, so that all participants can understand. So I will not be technical at all. So I will try to be as layman as possible. Is it okay?
Yeah, it is okay, sir, but even you can go for technical also, because many of the faculty members, they know the technical piece also.
No,
As and
I
when
will
it
go to
requires,
technical,
yeah.
but not.
Okay, not too like. That is
in
fine.
a totally layman perspective, but not too much technical. That will not.
Yes, sir. Yes, sir. That is fine. That is fine.
Okay. So let me start with this talk. The focus, whatever any aspect of life or education, the idea is to find wisdom from data. So let me say, for example, when anybody does research. So for research, what he does is he tries to acquire data in the form of research papers from multiple sources. Then he identifies papers of interest which are relevant to the problem he's solving. Then, based using going through those papers, he identifies the limitations of existing work and the motivation that he brings out to identify which problem is relevant and which has not been covered before. Based on that, he comes with some contribution, which is which is something new than what has been done earlier. That is something called knowledge. And once this knowledge is there, the only thing is in research, we don't put the knowledge into society, apply that knowledge into society, and that application of that knowledge is called wisdom. So I'll be talking in the context of how you derive wisdom. But before starting my talk, I would rather first initially focus on the industrial revolutions because the foundation is always there in the different industrial revolutions which we have come across. We had the first industrial revolution which started from 1760 to 1840. It was the invention of steam engines. When these came into picture, then there were mechanized production in textile, manufacturing, agriculture, all those took place. There was an apprehension at that time that people might lose jobs. Actually, that did not happen because of possibility of these factories and industries. Actually, eventually, it led to more and more jobs. Then we moved to the second industrial revolution, uh, which was around 1870 to 1914. It was the advent of electricity. That means, and the assembly line under in the era of mass production. So electricity was the major focus of the second industrial revolution, which led to mass production. Again, there was apprehension that people might lose jobs, and that actually did not happen. In fact, it created more jobs. Then we came to 50s to 2000, the era where we talked about electronics, computers, and the internet. And I still remember when personal computers came to India, again, people were thinking that, now machines are going to do most of the work and humans will not be required at all. Actually, in fact, what happened is the technology kept on improving, things became more possible, applications could have been developed, and you've already seen that software industry grew during that time. So again, more and more jobs were created. Now we are in the era of fourth industrial revolution. Here we talk about AI and cyber physical systems, IoTs, blockchain technologies. And again, people today who are in this era, they believe that AI is going to change the entire scenario and you will have machines that are going to do the work of humans. But actually, definitely to some extent, AI is going to displace certain jobs, like jobs which are repetitive in nature, like manufacturing, production, because they can have AI robots. But there are certain other jobs where AI cannot replace, like the human, where humans can do much better than AI, right? Thinking like strategic decision making, innovating, all these things humans will be required. So now the AI community understands very well that not even in near future, not even in distant future, you're going to have machines that are going to behave like humans, and therefore humans will always exist and their importance will always be there. So one way or the other, I'm trying to say that there are certain jobs machines can do, humans cannot do. At the same time, there are jobs that humans can do, machines can. And that is where today the community believes that humans and machines have to come together to achieve a bigger role to help the society, and that is what is going to be the industry revolution, where it is going to be all these cyber physical systems and AI for the society. So initially, I want to talk about this industrial revolution. Why? Because today we are in the era of AI, and it is said that if anybody is not using AI, he's going to get displaced. Even it is in the teaching community also, they say that if the teacher is not averse with AI, he's going to get displaced. And that is what is going to happen in this. Now, there were certain questions to be answered, and there is a philosophy behind AI. It talks about, can a machine act intelligently? Can it solve any problem that a person would solve? I think it is one way or the other we are trying to say, can a machine solve problems like a person solves it? Can a machine have a mind, mental states, and consciousness? In the same sense, humans do. Can it feel? Does it have emotions? Then are human intelligence and machine intelligence the same? Is the human brain essentially a computer? These three questions reflect the divergent interests of AI, researchers, philosophers, and cognitive sciences. Now, AI occurred in philosophy as a new form of behavioral. The idea was to study the behavior of human beings. Machines wanted to imitate the behavior of human beings. Behavioralism is a theory that tries to explain human behavior in terms of fixed rules that are derived from observing human beings. That is what machines learns the same. Machine wants to learn the same way as humans do. Humans keep seeing one thing again and again and later realize this is particular thing. Say, for example, how to identify various fruits and vegetables. Similarly, machine also wants to understand the same thing. The account for change in the brain behaviors propose the presence of a black box. So when it comes to humans, human brain is like a black box. It gets input and it produces the output. That means it takes a question, a query, and it responds to a query as an output. But it is so difficult to decipher how the output has been derived from the given input. And since it is unable to you can't decipher how the output has been derived because the human brain has found a way to produce an output for a given input. So human brain is conceptualized as a black box. And therefore, since human brain is conceptualized as a black box, therefore black box theory eventually became AI with the progress in the processing speed of the. And that is what it says. You know, AI concept is not new. It came somewhere in 50s in one of the universities in US. But at that time, the technology was not there. Not much more thing was out there. So it was difficult to realize the potential of AI. Then somewhere later in the 90s, it came again. But at that time, the AI scientists were very confident that technology has come. We are going to almost easily be able to make computers that behave like humans. But actually, that did not happen. The fact was that they overestimated AI and underestimated the human brain. And that made them realize that not even sooner, not even later, you're going to have machines that behave. The human brain is conceptualized as a black box. And when it is a black box, how would machine understand that how the human has produced the output for the human? And that made things much more. Now, this made the AI community to classify AI as weak AI and strong AI. When it comes to machines of today, all these computations, everything is based on simulation. It is based on simulated thinking. However, when it comes to humans, human think with consciousness. That consciousness leads to what is called the actual. So machines of today are under classified as weak AI machines. And the AI community aspires to have strong AI machines, the machines that can have consciousness, that can think like humans. Other classification that was there was that today's machines have ability to perform single tasks. You can't expect a machine that plays a tic-tac-toe to play another game, let's say chess. But when it comes to humans, humans have ability to perform multiple tasks. The machines of today come under the category of narrow AI. But again, the AI community aspires to have machines that are generic AI like humans are, that is, machines that can perform. From where the term superintelligence came. Superintelligence is a combination for generic and strong AI. That is, they want the machines to be super intelligent. That means they want machines that can perform multiple tasks while thinking this functions. And that is what AI community is aspiring to have. But they realize it as one fact, not sooner, not even later, you can have machines that are going to do. Alan Turing, he was instrumental in the Turing machine, which is the fundamental of computer. Alan Turing has another contribution. Alan Turing was was instrumental in the Allied forces winning the World War II because he had created an Enigma machine that could decrypt the location of the German submarine. Now, Alan Turing, 50 years back, reduced the problem of defining intelligence to a simple experiment. He said that you ask the computer any question, if it is able to reply to it in the same manner a normal human does, well, it is considered as. It can be explained through a simple experiment. There are many participants in a chat room. One of the participants is a real person, and one participant happens to be a computer programmer. The program passes the test, that is, the machines are called intelligent. If no one can tell, if the machine cannot tell, which one of the ten, which of them who is a participant is human. That means the machines have started behaving like humans, so it is so difficult to say which of them is humans. And that is when they say the Turing test will pass and the machines will start behaving. But again, as I said, it's far away from reality. It is so difficult to have machines that can behave like humans. The only fact behind it is the human beings. Turing test does not directly test if the computer behaves intelligently. The idea is not to test whether the computer behaves intelligently. The idea is to test whether the computer behaves like a human. And in general, the two concepts are humans. Human nervous systems can be thought of as being a novel by physical and chemical processes. If the human brain follows the law of physics, why cannot be simulated by a machine? And that is where the entire AI community thinks of. Now, when it comes to AI becomes relevant, and that's when the incoming data is more digitized form. That's why today AI is not only restricted to computer science, it has its own applications in humanities, social science, life science, environmental science, law, linguistics, and all aspects of life. But only what it requires is a digitized data. Data is the heart of AI technology. The ability of AI to learn and improve hinges on the availability of high quality digitized data. So if somebody wants to use AI, he has to ensure that he has a high quality digitized data. So digitized data, we understand what it is. But quality means that he should not have non-trustworthy data. He should have correct data. He should have consistent data. He should have complete data. He should have authentic data. He should have reliable data. All these things are very, very important. In today's scenario, we call because of this technology, data has become humongous. And this has data has become more and more complex. And today in this scenario, it is the data we are referring to is big. So before I move further, I will try to emphasize what big data means. Now, when we say big data, people think that big means volume. But here the big data is not volume. Big data is a complex data, and the complexity may be due to different reasons. But then the question arises, when do you call data to be big? We call data to be big when the data has become so complex that it is difficult to capture, store, process, analyze, and visualize using traditional tools and technologies. That means the traditional tools and technologies may work on data, but if it stops working on data, that is, this is not enough to use for data, that means the data has become big. The big in the data may be due to various reasons, and big in the data refers to complexity of data, which itself may be due to various reasons. So the Terabyte magazine talked about initially when big data came up, that big data exceeds the reach of commonly used hardware environments and software tools to capture, manage, and process it with a tolerable elapsed time for its large population. Big data refers to data sets whose size is beyond the ability of technical data tools to capture, store, manage, and analyze. This was a vacancy when this concept was at its peak. Now, why we are coming across big data today? Because we have been surrounded by smart devices, or we are wearing smart devices, or we are carrying smart. So machine data is being generated every day, either through mobile devices, the RFIDs, the sensor networks, the social networks, the internet searches, the automated record keeping, video archives, e-commerce, even the analysis of data has grown in size and made the data more and more. Now, when you say big data, as I said, big data is usually refers to the complex data. Now, this complexity may have different reasons. Say, for example, one reason of complexity may be its voluminous nature. As we saw that our brain has very limited access, they have very limited capability. That is, beyond a level, it cannot work with the same quality. So usually, when I talk about an example, I say that if I ask the students to appear for exams and I give them the choice, the syllabus comprises maybe of 10 chapters, and the student is given a choice whether you would like to give exam of 10 chapters after 10 days, or would you like to give exam of every chapter every day for 2 days. In that case, student would always prefer the second option than the first. That is because of the fact that human brain can comprehend to a certain level with a certain level of quality. But when that number increases, the quality deteriorates. The human brain can do very well with one chapter a day because the comprehension is much easier. So why this second option is better than the first one? Because we know that when we try to understand a book, we always believe that a word is easier to understand than a set of words. Set of words is easier to understand than a line. Line is easier to understand than a set of lines. Set of line is easier to understand than a paragraph. Paragraph is easier to understand than a set of paragraphs. Set of paragraph is easier to understand than a section. Section is easier to understand than a set of sections. Set of section is easier to understand than a chapter. Chapter is easier to understand than a set of chapters. And set of chapter is easier to understand than a book. So with grow, as it, the data grows, the complexity also. So one reason of complexity is due to the voluminous nature. What is the other reason? Earlier, when we talk about data, we used to talk about structured data, which were in the form of columns. But with the advent of internet, we are now talking about different types of data. We are mainly having these semi-structured and unstructured data. We have now video files, we have audio files, we have image files, we have text files. So much heterogeneity is data has is there. So comprehending such heterogeneous data to identify the context of it is not an easy task. So this heterogeneity also has made the data more and more complex, and that led to what is complexity. The third aspect that makes the data more and more complex is the speed in which the data is getting generated. Now we know that we have now sensor devices at multiple places. There are Internet of Things, there are other devices which are located at multiple places. They are generating data at a very rapid speed. Now, our traditional tools and technologies are capable of analyzing data with a specific speed. But now the data generation has become very rapid. So our traditional tools and technologies are not able to cope up with the existing high-speed generated data. That means this high-speed generated data itself has led to data being more and more complex. So another reason of data being complex is the heterogeneity of data. Now, next, when we talk about data, is the veracity of data. Now we have the internet. Internet is a huge source of data, but all data cannot be relied upon because there are certain data which are not authentic, which are not reliable, which are not trustworthy, which are not complete, which are not correct, may not be relevant, which may not be required. So you need to prune out such data before starting your analysis. So another difficult aspect is when you have data, you have to identify when you have data, you have to identify which data is to be used for analysis. So how do you identify which data is to be used for analysis is based on finding trust associated with every data and considering only those data which has a trust beyond a certain position. So as I said, big data is more means complex data, and the complexity may have several reasons. Say volume, maybe velocity, maybe variety, and maybe veracity. So its voluminous nature, the speed in which data is getting generated, the heterogeneous nature, and the trustworthy nature. So these are important aspects that make the data big. Now, now we see that the entire model has changed with time. Now, earlier what we used to do is few companies had data and few were generating and others were consuming. But with the advent of technology and AI, now all of us are generating data because we are all surrounded wearing or carrying smart devices. So we are all generating data and we are all consuming it. Just imagine the example of a Google map. The information that a particular fruit I will take more time depends upon somebody in that route generating the data and you becoming the consumer. Right? And that's why today's scenario is we are dealing with smart systems where everybody happens to produce data and everybody consumes. Now, so what we have done is initially in the database context, we talk about data initially with transaction processing, when we talk about simple conventional databases. Then we move to analytical processing because when we thought of analyzing the data, and today in the era, we talk about real-time analytical processing, where we talk about the concept of big data. Now, what is the difference between a system and a real-time system? A system is one which gives an answer. A good system is one which gives a correct answer to a given query. But a real-time system is not only requires a correct answer to the given query, but also requires that this answer should be given in a stipulated amount of time. So real-time systems are time-sensitive systems which requires answers to query in real time. That means in a defined stipulated time. So one such example of a real-time system is the air traffic control system, where no delay needs can happen. Now, today's when you talk about jobs in the IT industries, we focus on technology, the bottleneck in technology, because we want people to understand new architecture algorithms and techniques, as traditional architectures and techniques are no more capable of. Also, the skill required in new technology and dealing with big data is very. Now, as I said, the heart of AI is big data. But then, how this big data turns into wisdom? And that is the next question. So, we believe that the space in which the big data is getting produced and the pace at which we are able to analyze, there is a significant difference between the two. So that means most of the data remains not analyzed. So we have to find ways that how we can analyze. So we come across this pyramid which talks about from data to wisdom. and how wisdom is computed from it. Even at the bottom level, bottom side of the pyramid, you have data. If somebody asks you how to define data, data is a raw fact. It's a fact because it is derived. But when you collect such fact, you do not keep in mind whether it is organized. But this is a fact. And since it may not be organized or not, this is called a raw fact. So data is defined as a raw fact, which is neither organized nor meaningful, but it is a factual data. But then, if you want to analyze such data, infer something new out of it, you can't do it because you can't understand it. And why you can't understand it? Because data is neither organized nor meaningful, because it is a raw fact. So, in order to analyze it, you need to understand it. In order to understand it, you have to make it more organized and meaningful. And that organized and meaningful data is now you have this information with you. Now you can analyze such things. Now, what is the idea of analysis and what is the output of analysis? You do analyze such data to derive knowledge. Now, knowledge is not something which you already know. Knowledge is not something which already exists. Knowledge is something which is novel, which is non-obvious, which is hidden, which is interesting, and which is valuable. That means something you know of prior is cannot be considered as knowledge, but something which you did not know of prior is can be considered as knowledge. There is a famous example where they say that in a supermarket study, people wanted to identify what items are being sold together. They found many such cases. They found they may have found bread and butter are used. But we don't find any surprise that people buy bread and butter as part of an order because we know that if there's a bread and always people buy a butter. So nothing knowledge is not knowledge because it is neither non it's just not non-obvious to the system. It is very much obvious that somebody is likely to buy bread, is likely to buy butter. Similarly, the cases pencil and eraser, pant and shirt, jeans and t-shirts, these are nothing unusual. But they found that beer and diaper are being bought together more often. So when beer and diaper are being bought together more often, this is quite surprising, but because nobody in their wildest imagination can understand that beer and diaper would be related. So that cannot be understood in their mind. So the idea is because it is neither novel, it is novel, it is non-obvious, it is hidden, it is valuable, and it is interesting because we did not know that such a relation is there. This is what is called knowledge is something which is very much new, which people did not know. Right. Now, now once we have this knowledge, we don't know whether this knowledge is applicable to reality or not. It is sometimes it is observed that everything in theory cannot be practiced. So this knowledge may have come out of the theory, but we have to put it in practice to understand how good this is. Now, if you have this similar analogy, if I want to give an analogy to this, suppose I assume none of you are good singers. None of you are good singers, and if I ask you to sing a song without the voice coming outside, you would appear to be great singers because inside, without the voice coming outside, you would believe that you can sing a song very well. This may be a perception of knowledge. But if I ask you to sing a song with the voice coming outside, you realize how good a singer you are. So this is called application of knowledge. That is actionable. Now, actionable knowledge does two things. First, it validates the knowledge, whether it has relevance in the society. And then, in case validated, it enables you to utilize the knowledge. And this is what is called wisdom. Wisdom is called action. So that is what I wanted to make you understand that whatever study we do with AI, we start with data which is not neither organized nor meaningful, which happens to them. Then we transform it into information which is organized in data. Then we infer something interesting, hidden, non-obvious, novel, and valuable out of this information, and we call it as knowledge. And we then put knowledge into action. We realize the potential of knowledge, realize the benefits of knowledge, and that is peace. So ultimate goal when we talk about AI is to derive compute wisdom. So I would write that now one by one I will talk about the steps, little bit elaborate way, and then you will understand it better. So first, data science and industrial field that uses scientific methods, process algorithms, and systems to extract knowledge and insights from data in various forms, both structured and unstructured similar to data. The concept unifies statistics, data analysis, machine learning and methods to understand and analyze that phenomenon. It employs techniques and theories drawn from many fields in the context of mathematics, statistics, information science, and theory of what we are doing today, inviting data science is the fourth paradigm of science, empirical, theoretical, computational, and non-practical, and asserted that everything about science is changing, work, and impact on technology, the data. Data science may have many stages. It One is data acquisition. Data acquisition means extracting data from multiple data sources, integrating and transforming data in a homogeneous formats, and later loading the transformed data into a data warehouse. That means we try to extract gather data from multiple sources. Since this data may be in a different non-heterogeneous forms, we find a way to integrate and transform data into a homogeneous format. And then you load to a huge centralized repository like a warehouse, from where, once this data is stored, it is ready for further analysis. And the next stage, and this data acquisition stage, leads to data in that data to wisdom platform. Then the next stage happens to be what is called the data. Now, this, as I said, data may be neither organized nor meaningful now. So, data preparation. Data, as I said, data is a raw fact. It is neither organized nor meaningful. So you need to pre-process that data so that you can analyze the data. One thing is data cleaning to handle missing. When you insert data at multiple places, you give null values. Say for example, when you fill a Google form, you fill those. Usually, people fill those values where star is given against them. What about those values where star is not given? Some may fill, some may not fill. But if those attributes are required for analysis, they will report missing data. So you could need to find ways to fill those values. So you have many ways to fill those values, the mean of those column, and all these things you can use for filling. Then the next stage is data transformation. We know that data when we collect may be in different uh, scales. For example, somebody has stored an attribute like an age, it may vary from 20 to 60. But when it comes to salary, it may vary from 20 lakhs to 1 crore. But since these are on two different ranges, that people may think that they may have different influence on the optimization problem. So if you want to ensure or you want to bring the data to the same scale, you use mechanisms like normalization, standardization, where you try to bring irrespective of data in which data and the range in which was earlier, to try to define a new range for all the data. Maybe it is all data brings are brought to the range of 0 to 1. So that data transformation also is one part of data equation. Third is the handling of outliers. Can be used for fraud detection. Now, this is very important because, for example, what are these outliers and fraud detection? Suppose you are having a credit card in your country, the using it is in India, and one day without informing the bank you go abroad. And when you try to use the same credit card, the bank believes that this is a looks to be a fraudulent transaction. The reason being is they neither you have informed the bank, and the bank believes that this credit card was used within a particular country, but now it has been used outside. Is it in the position of a fraud? So suddenly banks will start writing messages to you, emails to you to understand is it you who is actually using the credit card or not. These type of things are called outliers, which are a different type of behavior. Then the other aspect is integrity. If you remember, I talked about the issue of veracity of information. Veracity means how how correct, complete, required, relevant, consistent, reliable, trustworthy data is. So data integrity is also very, very important. It talks about identifying data which is accurate, which is reliable, and which is trustworthy. So in research, there are several algorithms that are able to compute trust associated with every data. And in case if you are able want to find some data, you identify, you make some threshold level and only consider those data whose value is given later. Then you have what's called data reduction. Now we know that uh, all the data we may be surrounded by many material. You have many research papers in a journal, but not all research papers are relevant. So you need to only talk about data which are relevant to you. In a room, there can be furnitures, there can be tables, there can be chairs, and obviously surrounded by walls. But if the problem is to define and paint the wall, the furniture are not important, though they are there. And in order to arrange the furniture, you only need to dimension the floor, the walls, and the ceiling. And so that is what I'm trying to say. There's a lot of data available, but you need to identify what data is relevant and what's not. Beyond what sometimes we believe is the computationally expensive task. If there are not many attributes and features in data, the machine may not be able to compute them efficiently. So you might find ways to select relevant data, relevant attributes, or try to squeeze out the data so that you can make it computationally inexpensive. Again, the data reduction techniques. And you can see an example that if you have three attributes, say for example A, B, and C, where C always can and the C is actually A into B, then you need not store C because you always compute that value using A and B. So sometimes there can be multicollinearity in data, that is data may be related to each other. In that case, you have to identify the dependent data and the independent data, and we do not store the dependent data because we can always compute the dependent. So all these steps needs to be performed in order to make the data more relevant, more consistent, more complete, more correct, more reliable, more authentic, more trustworthy, so that it can further be used for analysis. In the third stage, what I said was data mining and modeling. The idea was so data preparation leads to what is called information. Now we want to analyze that information so that we perform data mining and modeling. Now, data mining and modeling means that we are not looking for the ultimate goal of this step is to lead to knowledge. And when I said knowledge, knowledge is all about finding something new. So finding something valid, hold on new data with some certainty, something which is novel, that is known as to the system, something which is useful, should be possible to act on them, and should be understandable, human should be able to interpret the pattern, should be interesting, and should be valid. And that is what we look forward to. So data mining and modeling leads to what is called knowledge. So when we talk about data mining and modeling, we come across the term of machine learning. A machine learning, you can understand, it is how a machine learns from data. There can be different ways a machine wants to learn. One way is that I learn from the data because the data is already tagged. Let us take an example of this scenario. What do we mean by this? Again, let me come back to the example of a credit card. Suppose somebody, some agent is after you that why don't you apply for a credit card? And when you try to apply and you fill the form, then maybe it is possible that after a week you may get a regret that the company cannot issue a credit card. Then you feel surprised that if the agent was after me, why the company is not providing me a credit card? The reason is very, very clear that how has become possible. The reason is there are past credit card holders of the bank. Based on their credit history, they have been identified as good and bad. And based on that, a model has got created. Any new customer who comes to the bank, this information is fed to the model, and the model predicts whether the customer is likely to be good or likely to be bad. If the model predicts that customer to be good, please issue the credit card. And if the model predicts that the customer is bad, please deny the credit. So this case, where you are working with data for which the tag values have been assigned by the bank or the tag values exist, such learning is called the supervised learning. This is also called a priori classification, where the classes are not known a priori. The other type of learning is when the tag values are not available. Let us take another example. You know, when the new students come to a class, they may have come from different places, different states, maybe different countries. Initially, when they come and meet in a class, and nobody knows each other, what they do is they start interacting with each other. Then, after a month, you see the groups have got created in the class. Groups have similarity in terms of their hobbies, in terms of this, just the interest, in terms of their likings. That is how the groups are formed. So just understand, initially this data was not labeled. However, after some time, when people understood the similarities and the likes and dislikes of people, there were groups that have emerged, which are also called classes that are created out of data. Now, this is a case of what is called unsupervised learning, where we try to create classes out of data. Theory classification, which is classes are known, not known a prior, however, classes are created out. The third aspect of machine learning is called the reinforcement. If you recall that when you try to play a new game, initially you perform bad. Then you learn from your experience and the environment. Next time you perform a little bit better. And then what gradually happens is one day you become an expert of it. So reinforcement learning is a hit and trial method where initially you have more of penalties than rewards, and gradually over a period of time you have more rewards than. So this is another type of learning machine does, which is called the reinforcement. There's another field. There's another field that is another branch of artificial intelligence, which is inspired by nature. Now, nature, the creatures in nature are not educated, but they don't have the brain like humans have. But they have, they try to work together to exhibit it. When the intelligence exhibited by homogeneous beings, it is called the swarm intelligence. When the intelligence is exhibited by a heterogeneous group of individuals, it is called the collective intelligence. So when you talk about inspiration by nature, there are certain problems which even algorithms can solve. So if you see, the idea is to find, suppose there is a problem and you want to find the best solution. But there is no way you can find the best solution. But then let us understand, how do you find the best solution? In order to find the best solution, you need to have three steps. In the first step, you have to find the number of possible solutions. In the second step, The second step, you need to find what are these possible solutions. And the third step, you need to evaluate each of these possible solutions to find which amongst them happens to be the best solution. In real life, more than 90% of the problems, there is no way you can find the best. So, so that means that there is no way the reason can be the first, that is, it is so difficult to find the all possible solutions, number of possible solutions. The reason can be second, it is not possible to find those number of possible solutions. The reason can also be third. Even if you find those number of possible solutions, you may not be able to evaluate all possible solutions. Let us take a simple example. Let us take a case of a traveling salesman problem. A traveling salesman problem is said like this. You have say n cities. A traveling salesman has to start from one of these cities, has to visit each and every city at least once, and at least twice, and come back to the original city. The objective is to minimize the distance traveled by the traveling salesman. So the objective is to minimize the distance traveled. Now the question is that how do you, so how many solutions are there? Say for example, there are two cities, say A and B. Let us come to those three statements. There are two cities, A and B. So possible solutions are two. What are these two possible solutions? A, B, A or B, A, B. Then that is the second. The third stage, evaluate all possible solutions. So we compute the distance of A, B, A and B, A, B, and then find which distance is the smallest. Suppose the number of cities are three. In that case, say A, B, and C. In that case, the number of possible solutions, because it's a factorial problem, the number of possible solutions is going to be 3 factorial, that is 6. What are those possible solutions? I can say A, B, C, A, C, B, A. Similarly, B, A, C, B, B, C, A, B. And similarly, C, A, B, C, and C, B, A, C. All 6 possible solutions I can find. And the third step is to evaluate these possible solutions. So we compute the distance in traveled in each of these 6 solutions, and we consider the route where the distance is the least. But suppose this is 200 cities. In that case, since being a factorial problem, you won't be able to even find what are the number of possible solutions in place of 200 factorial. Forget about the next stage. Such problems for which you can't even find the number of possible solutions, such problems you can never find the best solutions. For this, you use a different type of algorithms, because the idea is to find a good set of solutions, if not the best. So nature has provided ways to solve it, provided ways to solve such problems. We are aware of the Darwin's theory of survival of the fittest. That leads to what is called the genetic economics. So what Darwin's theory says that fitter survive and are likely to survive and move to another generation, and less fitter are more likely to die. And there is limited amount of resources for which these organisms compete. And over a period of time, more and more fitter individuals will be produced. So it is said that in a period of time, you have much more intelligent and better individuals. So if you see the analogy of solutions, if we want to find a solution, if we try to keep making solutions and deriving solutions from the next generation, over a period of time, over a period of generation, we are going to have a good set of solutions. This such motivation has led to algorithms like the genetic algorithms, which are able to find solutions, a good set of solutions to problems like the privacy. Other, let us understand the case of ants. You may have noticed ants in your home when they are together, but initially they are not together. Initially they are spread out. The goal is to find food. The ants that find food on the way back, they lay a chemical substance for the pheromone. Suddenly, certain paths have high density of pheromones, which are indicating that if you follow this path, will lead to a food source. And then what happens eventually? All ants start moving together on that path, so that leads to the food source. This foraging via of ants has led to algorithms like the ant colony optimization that has solved such complex problems like the travel sector. The other aspect is the birds. Birds are flying in the sky, you can see they do not communicate with each other. However, they communicate with each other because they are also looking for food. All the birds communicate the locations of the food they have observed and communicate with each other. And suddenly they compute that which of the bird has found the best food, and that bird then leads the flock of birds to the food source. This foraging of behavior birds to the food source has led to algorithms like the particle swarm optimization algorithms that has solved complex problems like privacy. Now, you know the bees look for food in flowers. They travel distances to flowers, and some of the bees then they are supposed to come back home. When they reach the honeycomb, inside the honeycomb there is a dance floor, which is surrounded by other bees. They're waiting for these bees to return and perform the dances. These bees returns and perform dances like the bridal dance and the round dance. The idea of these dances is to recruit bees to the food source. The bees who have identified a huge large amount of food source have this dance more vigorously done. Sometimes some other dancing bees are thrown out of the dance floor. So that they can recruit more and more bees. This foraging of bees for food has led to algorithms like the bee colony optimization that has solved complex science. The other aspect is the cuckoos. We know that cuckoos have a melodious voice, but they usually do not have their own nest. Usually they lay eggs in the crow's nest, but not any crow. They lay eggs in the crow's nest where their eggs resembles the texture of the egg of the crow, so that the crow is unable to distinguish its egg from the cuckoo's egg. Not only this, the cuckoo egg hatch faster. The newborn cuckoos, the first thing they do is to throw away the crow's egg outside the nest. Above all, cuckoo has ability, the newborn cuckoo has ability to mimic the voice of the crow so that they can have larger shapes. This searching of cuckoos for such nests has led the algorithms like the cuckoo search algorithms that has solved complex problems like one traveling seed. I have already discussed about the neural networks, how the brain in which the neurons interact with each other to perform tasks. So that is how the motivation is. And as I said, the human brain is complex. Even if you use techniques like artificial neural networks, you will find that you have an input, you have an output, but you will not be able to decipher how the input has been given. Output, that is what is the reason. And this inspired nature is another branch of artificial intelligence that has led to solve problems for which you cannot find the best solutions. The aim of such algorithm is to find a good solution of the problem because the best solutions. And I will say, once once the knowledge has been derived using these AI-based techniques, the next thing you have to do is visualization and action. As I said, knowledge has to be put in action. In order to put in action, we need to understand the knowledge. Now let us go back to the case of the beer and diaper example, where we found that knowledge in the form that beer and diaper are being brought together more often has been derived. Now you need to understand, visualize, to understand what may have been the reason of this. So there can be many such interpretations to this problem. One such interpretation can be young couples go on a long weekend drive and drink beers and then diapers for their child. Another interpretation can be young couples watch American football match on the weekend. In order to not get disturbed with the child, have diapers for their child and drink beer while watching those matches. So the target people were the young couples. And then the strategy can be anything. You may give discount on beer if somebody buys diaper. You can give discount on diaper if somebody buys beer. You can have you can define that maybe 10 diapers, you get a beer free. With one beer, you get two diapers free. Maybe you can put the diaper and beer on the addition shelf. It would be far better to keep them on exchange shelf because you know that somebody who looks for diaper, who will look for beer, in between he may buy things. So this application actionable knowledge is called understanding. So the ultimate goal is to put the knowledge into action. For that, we need the results of the modeling are presented in a meaningful manner, interpreted using visualization tools for decision making. The decisions arrived at are put into action or executed. And this is leads to what is called. Now, as I said, we have constructed a model that has lead to wisdom, but the model is based on the data. But what happens if the trends in data changes? So you need to do model recomputation. Because if you do not, if the data trends changes and the model remains the same, the model will become obsolete. So you need to keep you have to keep cater to the trends in data, and accordingly you have to recompute the model. So the model, so that the model is recomputed so that the new model keeps in line with the data that is there existing. Right. So data or characteristics of data changes over time, and the accuracy of the model deteriorates. Model needs to be recomputed or updated periodically to cater to new data produced in the present model. Model recomputation results in a better accuracy. And this is the stage. And then once you have the recomputation means, again you go back to data, again you go back to then you transform it to knowledge or information, then you transform it to knowledge. And the question is, as I said, when I said data science strategy, I started with data and acquisition, which eventually led to data. Then we have data preparation, which leads to this. Then we have data mining and modeling, which leads to knowledge. Then we have what is called visualization and action, that leads to this. And as I said, data keeps changing, and modeling needs to change. Now the question is, what is this analytics all about? There's nothing called one type of analytics. Whenever you have a problem in hand, first thing you need to understand is what is the problem. That is to understand what has happened. This is what is called descriptive analytics. Then you have to understand why it is a problem, why a problem has occurred. That is what is called the diagnostic. Then you try to find what is going to happen next. What are the consequences of the problem? And that is what is called the predictive. And then you find various alternate solutions to solve the problem. This is called the prescriptive analysis. And to find the best solution amongst all possible solutions, that is called the decisive analysis. So when you do analytics, you need to start with descriptive analytics to understand the problem. Then you move to diagnostic analytics to find the reason of it. Then you have to move to predictive analytics to find the consequences of the problem. Then you have to find the prescriptive analytics to find the alternate solutions. And finally, you should do decisive analytics to find the best solutions. So, what is the ultimate goal of analytics? Ultimate goal of analytics is from sensors, data collection, measurement, observation, to monitoring and alerting, to sense making data and analytical science, which we have talked earlier, to sense making, which is taking in ROI. Now, ROI are very interesting. Return on investment. Now, what is this return on investment? It is when you think from the financial aspect, in any aspect, in real life, it is not profit, actually, it is wealth. And when we say wealth, wealth is something which is long term. Profit is something which is short. So if you look for short term profits, you may not have long term wealth. And so the ideal situation is when you set up an industry, set up a business, set up anything, initially you may face losses because you want to gain goodwill. And once you gain goodwill, you actually eventually lead to wealth. So the idea is to find wealth and not profit. And that is what is the goal of analytics. You may lose the battle, but you may still win the war. The war is the wealth and the battle is the wealth. So that is what idea is. So ROI is not always immediately obvious. It may results of analytics may be available only after years of analytics. It requires long-term effort to develop a sustainable. When we talk about ROI in terms of health, it may be moving from predictive to preventive. It can be enabling personalized medicine for shortened time. It can be recognizing and predicting spread of infectious diseases. And when it's to crime, we talk about aggressively recognizing and combating syndicated multi-part. It can be predicting potential crime locales and time to preventatively environment, predicting weather floods, earthquake, volcano eruptions, all these comes in the environment. And it can be computer security in terms of setting system. So ROIs are usually long term, their profit are short. When you talk about data science, predicting more knowledge, it's well, it's an AI has different social AI in India social perspective. It has Niti Aayog focused areas. Yeah, they are healthcare, they are agriculture, education, smart cities infrastructure, smart mobility and transportation, retail, manufacturing, and disasters. I think I have 10 minutes left. Yes, Srinivasi, 10 minutes? Hello. Anybody listen?
You can say.
10 minutes left.
Yeah, please.
Let me elaborate work on these slides. What are these healthcare issues? You know, the idea in the area of healthcare is what? Healthcare is today, there are few hospitals and, and there is a huge line of patients. Especially when it comes to hospitals like AIMS, people come from different cities and come to Delhi and you find a lot of load and a lot of queue for appointments. Now, AI can very well help you. AI can bring hospitals to people rather than taking people to hospitals. How they can bring hospitals to people is they can have systems that can be developed so that with basic amenities that can be diagnosis can be done at the rural level, and these are fed into systems which can help in diagnosing the disease. Now, instead of people going somewhere, the past data of patients have gone through various tests and were diagnosed with a certain type of disease. Now, if this data becomes available to an AI-based system, a system can do modeling on such data to generate a model or a system that can predict or diagnose the disease for a given set of tests performed by the patients. So in that case, the diagnosis can be an indicator of a disease and it can replace a doctor also. What you need to do is at the rural level, you can go through various tests. The results of these tests can be fed into the system, and the system can easily diagnose your disease. So instead of people moving from places to the cities for cure, they can bring the hospitals to their rural area if AI can be used to define or design such systems which can do such things. So healthcare is one area where AI can be very much used so that it can help in various diagnoses AI in the form of expert systems is already being used for performing surgery operations. It already do because they help in directing or advising the doctors how to go to the next step of research. The other area which Niti Aayog identified was the area of agriculture. Now, agriculture, again, the same issue. The farmers are in the field, their crops sometimes goes down or their crops go under diseases. So, based on the past data, when we have kept data related to a particular type of an image of a particular leaf or a crop or the land or the fertilizer or other things, so we know what type of diseases crops have undergone. So there is a data with certain tag values in terms of the disease they had. Now, if this data is used to train a model, so that if you give input based on the situation of the leaf or the image of the leaf, the model can easily diagnose whether a disease is likely to happen or disease is already there. And this type of advices, this type of prediction can be given to the farmers, and farmers can also be given advices what type of take so that disease which is likely to occur in this crop can be avoided. So again, the same thing. Instead of farmers going to the cities for advices, the advices can be given to the farmers through these AI-based systems, so they can ensure avoid such crop diseases or erosion of lands, the soil, so that you have better crop harvesting. Not only that, it can also tell you about the most appropriate quantity of fertilizers and manures that should be put, so that neither it affects people who eat them, it has a proper impact on the growth and better development of these crops. Again, AI can play a very important role in the field of agriculture. The third field, which is very important where AI can play a role, is the area of education. Now we are in the era of 1:1 education, and we are moving towards an education where it has to be 1:1. Today we see the entire class as one. So what happens is, if we get a response from one student, we believe the entire class has understood the topic. Now, what can be done is, in a class you can identify fast learners, moderate learners, and weak learners. And accordingly, you can introduce remedial classes for these weak learners and moderate learners so that they also improve with time. And AI it can perform well to identify these learners, different type of learners, and try to have course material designed according to different type of learners. So that it moves from 1:1 to 1:1, so that every type of learner has a different type of course material and instructions, so that makes them easier to understand things. There can be tools made where while the student is going through the e-material, there can be several prompts that may occur, which keeps asking the student about the question related to page he's reading, to understand how good the student is able to comprehend the text in the reading, at the same time how well he is able to answer these questions. This enables the system to understand where are the limitations in the student and how these limitations can be addressed. So another area where AI can play a very important role is the area of education, where it can identify students who require help and develop. The other area of the education, other aspect of education is the education where the cross enrollment ratio at the school level is very, very high. However, the school is not able to retain the students. The retention rate is very, very low. So that means the student takes admission in the school in the primary level, but he does not go till maybe fifth class or eighth class and he drops out from the school. AI can do early prediction of such students when they come into the school, so that they can create some remedial actions, various mechanisms in terms of facilities, so that students does not. So this is another place where AI can be of great help in the primary school. The fourth area and the fifth area, we talk about smart cities or smart mobility. Today we talk about driverless cars, and you know AI can play a very important role. AI is enabled to have these cars which can run without a driver or some with minimal driver assistance. Then we are talking about smart cities, where there are proper smart parking, smart area, where you can have all smart facilities. Instead of doing much, the systems will do much for you. That also is another purpose of area. AI initially when it started in the area of retail. And you usually see the e-commerce websites where everybody's homepage is different because it is based on your preferences. So two people may open an Amazon account, but both of them may have different products. It totally depends upon your preferences, your past access, your past buying, decide what is going to the homepage. AI has played a very important role when it has promoted e-commerce or e-business sites. Then AI can play very important role in manufacturing. There can be AI robots, AI systems, because manufacturing happens to be more of a repetitive job. So AI robots and AI manufacturing units can come into picture, which can enable automatic manufacturing of things that to precision manufacturing, unlike which will take and which will avoid the errors that humans can make. Then another area is disasters. We sometimes have a notion about disasters, but usually the hazards we come across are natural, and these hazards eventually turn into disaster. So usually, if I say a natural disaster, I would rather prefer to say natural hazards. Earthquake and other things are natural hazards. And when these hazards lead to loss of life and property, they are defined as disasters. AI can too. So understand one thing that these hazards eventually turns into disaster when they lead to loss of life and property. All hazards do not become disaster. Earthquakes may come daily, may come eventually. There are countries where earthquake comes daily, but the earthquake does not lead to loss of life. It remains as a natural hazard without turning into disaster. AI can be of great help to identify these hazards at the earliest so that enough time is there to ensure that these hazards do not turn into disasters. There can be several models where AI can be used where they try to prevent the hazards turning into disasters. So various AI perspective of AI in the Indian social perspective has been healthcare, agriculture, education, smart cities, smart mobility, retail, manufacturing, and businesses. So the positive time was there, so I did not go much into detail. I have these slides, but I'm not going to say this is water disasters, and that is so. This is, I think, this. Summary: the AI strategies aimed at primarily guiding an inevitable wave of change for quicker and better impact. The AI ecosystem is rapidly evolving in people's societies into uncharted territories. The questions are we ready to manage data ethically? How do we build to divide? Ethics of AI is very, very important because if that privacy and security data is a major issue when it comes to AI. So AI, should be an accountability. If anybody's data is being used, he should be informed. Also should be informed that for what purpose the data is being used, and that is very important. So that will ensure privacy and security. Bringing these questions into the open is the most important step in ensuring that AI advances create a better system. With this, I would like to stop. If you have any questions, please.
Yeah, thank you, sir. There are a few questions maybe in the chat box also.
Let me.
Some participants, they are asking for your presentation also, sir. Kindly share.
That let me see whether I
Yeah.
can share or not. But if you have any questions, please.
Dear participants, please, you can pose some questions so that because sometimes very senior professor and having so much of knowledge on computers, and he's the actually a founder professor at JNU Computer Science Department. You can interact with him.
Please ask. Two questions. Can you tell me how to enlarge this screen? I'm looking this. Hello.
Or you can unmute and you can interact with Professor.
I'm not able to read it full screen. Hello. Can you ask? Yes, tell me. Yes. Anybody wants to ask questions?
Dear participants, you are allowed to unmute yourself. You please unmute your mic and you can interact with Professor.
Sir,
Yes.
Yes, sir. Please go ahead.
good morning, sir.
Hmm.
I am very happy with your presentation, sir.
Hmm.
I wish to ask one question, sir, please.
Tell me,
How
tell
it
me.
is going, how it is going to affect the common man?
It is going to affect the common man in a very, very impactful way. See, let me understand, make you understand.
Sir?
I said
Sir?
that, are you able to hear me?
Yes, sir. Yes, sir.
Okay, see, I said initially that not sooner, not later, we will have machines that are going to be replaced. But that, what is the then? What do you see the advantage? Advantage is that AI improves the productivity. But there is a big disadvantage also because human beings have this consciousness, they have emotions. Now, the machines are not going to have emotions. So they can become ruthless also. So they don't find an intermediate way. They can be very impactful. They only know 0 and 1. They don't know any value between 0 and 1. So AI can have a very, very strong impact on the society. Definitely one impact it may displace some of the jobs. But the good thing is that it may create some other jobs which are based on strategic thinking.
Not in the
The
sense
other
of,
thing is,
excuse me, sir.
hello,
Not in the sense of jobs and services, I am asking, sir.
Huh. In
With
terms of,
respect, sir, not with respect to the jobs, I am asking, sir. For the common man, how
that is
it
what,
is,
how it
how,
is going to help. Let me take an example.
sir,
Suppose you are any individual wants to do shopping. So is it, I will take an example. Suppose you
sir,
go, today you
sir.
go to market to buy things. So what you do, the vendor knows you are going to bargain. You also want to have an intention to bargain. So what is today is happening is that vendor will quote a high price, you will quote a low price, and you keep bargaining and eventually buy a product in a price in between the two. But what happens if AI becomes successful? Say, like for example, that what happens if AI becomes moderately successful? The same thing you go to a market, vendor would know before you enter the shop how desperate you are to buy a particular thing, which thing you have come to buy in the market, and what is the destination that you are going to buy the same thing from his shop only. He will be having all data about you. So he knows. So he will quote a price without any bargain. You may leave the shop, but eventually you will come to the same shop and buy that thing. But if the AI becomes very successful,
Yes,
then
sir.
you don't even need to go to the market. The vendor will come to your doorstep, bring the bill, and say, this is what has already been consumed at your home. This is what I have brought. Buy this. Now, this is going to have a very strong impact because the
Yes,
common man will be the vendor, the machine, the companies are going to benefit a lot because of AI. But it can hurt a common man because AI can understand what is your intention, what is your behavior, or what you are thinking, what is lacking, what you want, how desperate you are, so that they can sell their products at a price defined by them, not defined by you. So this is possible when the AI. I think something like this you wanted to ask, isn't it?
Okay, thank you, sir. Thank you, sir.
Somebody else also has raised hands. I would also say, AI will improve productivity, but at the cost of reducing the ability of the human being. Now, machines are doing more work. Humans have stopped doing the work. But the question is, when the machine stops working, what is the human going to do? Say, for example, today a Google map is used by an Ola driver to take somebody from a source to the destination. But say one day this Google map stops working, what will happen? Even the Ola driver would not know how to move to the destination. Just imagine how much dependent we have become on the machine. And their machine stops working, you become so vulnerable that you don't know how to go about things. And that is what AI can have impact. AI can dictate what you're going to do. And that is what is there. Yes, somebody else? Somebody else was trying to ask a question. Hello. Hello.
Hello, sir. Sir.
Yes. Yes.
Thank you, sir. Thank you, sir.
Hello. Yes. Tell me.
Especially in healthcare, the in
Huh?
healthcare,
Your voice is not clear. Your voice is not clear.
healthcare.
Hello. Your voice is
Sir,
not
in
clear. There's
hello,
in healthcare.
sir,
Yes.
sir. Now is audible, sir.
Tell me in healthcare.
In centric, so many diseases, so many impacts are going on in our body, especially in liver centric. How can we are going to implement artificial intelligence in this?
How will we? Your voice. There is some internet problems in there. The voice is not clear. Hello.
Hello.
Chat box. Can
Healthcare
you mention the
centric,
chat?
in liver centric. So, okay.
You write it to the chat box. Will that anybody else have a question?
Yes, sir. Yes, sir. May I ask you, sir, one question?
Okay.
Hello.
Tell me. Go ahead.
Okay. So, I'm just asking how this AI can reform the agriculture input prices.
Yes. AI
So,
can be a. Yes. AI can be used on from pricing also. See, today what is happening is AI can set up the price based on the past history in terms of demand and supply. Okay. AI can be used based on the past because past history, they can keep on talking about them. Today also you see these prices in the airlines, in the railways, you see the price, dynamic pricing is there. So you notice this dynamic pricing, isn't it? So, hello.
yes, sir.
Rahul,
You are audible, sir.
you are noticing this dynamic pricing. Somewhere
Right, sir.
behind
Right.
this dynamic pricing is AI. Now, suppose somebody wants to go to south of India. In South India, the best time to go is December and January. The weather is the best. Okay. Now you see that when this time comes, the airline price increases. The hotel price also increases. So there is a past history which decides how. Similarly, crops. When you talk about agriculture, today, this laws, if you remove the broker out of the place, it is direct selling, the farmer selling directly to the market. Now, based on the demand and supply, the AI can help you decide what is the price. One day the price may go down, one day the price may go up. for example, let us see these Amazons which sell products. Now, these pricing goes up and down when it comes to this issue. Somewhere on the line, AI is being used because they know that at what time, in what type of this time of the year, the pricing is what type of price is the most appropriate price for increasing the sales. Definitely today, AI has been used for dynamic pricing at many places, and which is also there in the case of farming. So when the farmer comes to sell it to the market, it can really help the farmer in deciding pricing. It totally depends upon the time of the year, the demand and supply that is there, and the past history.
Yeah, sir. Yeah, sir. I got it. But the point is that, sir, suppose at the time of cultivations or at the time of sowing, farmer can farmer will be aware these prices 5 months, 4 months before, because most of the crops of durations 4 months.
You're absolutely right. Now, see, in the weather condition in India, you find unprecedented rains also. Unprecedented drops. But the farmer will be aware of one price at a particular time, maybe 3 months before also. But this price may not be final because it may fluctuate here and there depending upon that situation at that time. Yes, he will have start with a certain price, the AI product, but over a period of time, it will be dynamically, things might change based on at that time, point of time, what is the demand and supply. So definitely,
Yes,
initially
sir, got it.
he knows, but that will be dynamically changed because of the demand and supply. There are various factors that we influence. There's a standard deviation. When you say a mean, there's also a standard deviation. There is a
Right,
min
sir,
value
right.
and a max value. It can, farmer may have an idea about the range in which the crop may be. Anything else? Sir, is there any tool against AI in identifying the data is biased or unfair, or it is only depend on trained data only for prediction decision? See, this bias is a very, very, very important issue in artificial intelligence. Say sometimes when you get an answer from a chat GPT also, the answer may be linked to a certain type of ideology, sometimes some bias. So if you want to reduce the bias, you have to work in heterogeneous type of thing. You cannot work with a similar type of data. What will happen is that will introduce bias to it. For other type of data, the results may not be accurate. So bias is a very, very important area when you talk about AI. So bias can be reduced only when you work on heterogeneous type of data, where data is collected from several sources. It's like taking opinion from different people. Say, for example, when you form a high-level committee, say with education also in a state or a country, you try to involve people from different streams of life. Not only from education, you will from film industry, from IT industry, from business people, every type of person is there. Because if you only consider one type of person, it will create bias and it will not cater to other type of person when a policy is being defined for the country. So the heterogeneity in terms of the capability and expertise that we involve in deciding a policy will try to minimize such bias which may be there, so that a more consensus policy is defined which may be neutral to everyone. So that is where bias. Bias is still a very important area. There is a very interesting scenario which happened that one AI based tool wanted to scrutinize applications. In fact, it scrutinized all male applications and it reject all female applications. So definitely that AI application has bias. Is it okay?
Yes, sir.
Anybody else? Any questions? Anybody else?
If anybody, there are no queries, can I say thanks to Professor T.V. Vijay Kumar Singh? Sir, really, it's a wonderful presentation. Many people, they are very much interested. And in future also, we will invite you for further sessions, sir.
Definitely, no
And the
problem.
title itself is Yeah, the title itself is really very apt
So,
for
I
this session.
remember
Yes,
I would like to give one statement, which usually I
sir.
give on this title is one should be wise rather than being otherwise. Because wise people can do wonders,
Exactly.
and people who are not wise, that is otherwise. In fact, despite of being knowledgeable, despite of being intelligent, if they don't know how to utilize their intelligence, they still remain otherwise. So, my suggestion is be wise, not rather than.
Yeah, you very beautifully described the even Bloom's taxonomy also. Our earlier days, it is called knowledge, and now we have um, uh,
This.
built upon this wisdom as the creative apex of this Bloom's taxonomy pyramid. For that caption also, I would like to thank you very much, sir. It's really a very informative session, and definitely all our faculty members will enjoy this. And on behalf of all the faculty members, I request you to share the presentation also, sir.
Thank
On
you and
behalf
best
of
of.
AP State, on behalf of AP State Council of Higher Education, Professor K. Madhumurthy ji, I would like to thank you very much. Thank you, sir.
So thank you
Is there
very much
anything
and
you
best.
want to say?
Thank
Yeah.
you very much and best of wishes and best wishes from.
Thank you, sir. Incidentally, sir, AP has got so many data centers.
Very good.
That is also one important aspect so that everybody should
If you
get
require my
into.
help to work on that data, please let me. I
Yes, sir.
specialize in data science. Database is my core
Yeah.
specialty and AI. Okay.
Definitely, sir. We can design some more courses, some more talks on this webinar platform. Definitely, I would like to invite you in other episodes also.
Oh, thank you.
Thank you, sir. Thank you very much. I thank all the participants. Please share the YouTube link to all your students. It's my request, and so that as it is part of curriculum, it will be very, very beneficial to students as well. Sir, shall we close now?
Okay, thank you.
Thank you, sir. Thank you very much. Thank you.
Hello.